Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of derivatives. So as per the problem, find the critical points for the function. Use the first derivative test to determine whether the critical point is a local maximum, local minimum, or neither. Then find the x and y intercepts and sketch the function. So first we have to find the critical points for the function. So critical points are points at which the derivative of a function is equal to 0 or undefined. So we have to start by finding the derivative of this given function. So the derivative of the given function will be, so y prime equals, so we have to use power rule to find the derivative of these two terms. So the derivative of x to the power 4 will be 4 and then x exponent 4 minus 1. So we move the exponent to the front and then we subtract 1 from the exponent. Now in the next term, minus 8 is the coefficient, so it stays the same. And now we'll use power rule for x squared and we'll move the exponent to the front and subtract 1 from it. So now we get y prime equals 4x cubed minus 16x. So the exponent of x is 1, but we don't write 1 as an exponent. Now this is a polynomial function, this y prime, and polynomial function cannot be undefined for any x value. So therefore we just have to find the x values that will make the y prime equal to 0. So we sub in y prime as 0 on the left side and we have to solve this equation. So the first step is to do common factoring on the right side. So we can factor out 4x. And in parentheses, we are left with x squared minus 4. Now we can factor this further by using the difference of squares method. So we can rewrite x squared minus 4 as x squared minus 2 squared. And now we can break it up using the difference of squares factoring method. So x plus 2 times x minus 2. And now we'll get three cases and we'll use those three cases to find the critical numbers. So first case is for 4x equals 0. The second case is x plus 2 equals 0. And then the third case is x minus 2 equals 0. So in the first one, so we divide both sides by 4. The 4's on the left side will cancel each other out. So we get x equals 0 over 4, which is equal to 0. So now in the second case, we have to subtract 2 from both sides to isolate x. So the 2's on the side will get cancelled out. So we get x equals negative 2. And in the third case, we'll add 2 to both sides. So the 2's on the left side will get cancelled out. So we get x equals 2. So we got three critical numbers. Now we'll sub in these x values one by one in the given function to find the y values for these critical numbers, and then we can write the critical points. So let's start with x equals 0. So if x equals 0, so we get y equals 0 exponent 4 minus 8 times 0 squared. So that will be just 0 minus 0, which is equal to 0. So the first critical point is 0, 0. Now we can use the other x value, negative 2. So we'll sub in x as negative 2 in the given function. So negative 2 exponent 4 minus 8 times negative 2 squared. So y equals, so negative 2 exponent 4 is equal to 16. And then minus 8 times positive 4. So negative 2 square is equal to positive 4. So we get y equals 16 minus 32, which is equal to negative 16. So the second critical point is negative 2, negative 16. Now we can find the third critical point. So we'll sub in x as 2 in the given function. So we get 2 exponent 4 minus 8 times 2 squared. So 2 exponent 4 is 16, and then minus 8 times 4, which is equal to 32. So y equals negative 16. So the third critical point is 2, negative 16. So these are the three critical points for this given function, and we are done with the first part. Now we have to use the first derivative test to determine whether the critical point is a local maximum, local minimum, or neither. And for that, we'll use the expression for the derivative y prime equals 4x cubed minus 16x. So now we can use the number line method to find the sign of the derivative on both sides of these critical points. So we can start by drawing a number line. And now we can plot the critical numbers. So the critical numbers are negative 2, 0, and 2. So these critical numbers divide the number line into 4 parts. So we'll have to use a test value in each part to find whether the derivative is positive or negative in that part. So we can use negative 3 in the left part, and between negative 2 and 0 we can use negative 1. Between 0 and 2 we can use 1, and to the right side of 2 we can use 3. Now we have to find what y prime is at x equals negative 3. So we get y prime equals 4 times negative 3 exponent 3 minus 16 times 3. Now we are only interested in the sign of the result we get for y prime and not in the value. So we just want to know whether the y prime is a positive or a negative number. So in this case, the y prime equals 4 times, so negative 3 exponent 3 will be equal to negative 27, and then minus 16 times 3 is 48. Now when we combine these terms, we'll get a negative value for y prime. So that means the derivative has a negative value to the left side of negative 2. Therefore, the function is decreasing on the left side of negative 2. So I can write it as decrease. Now we can find the sign of y prime for the test value negative 1. So we do y prime equals 4 times negative 1 cube minus 16 times negative 1. So 4 times, so negative 1 to the power cube is negative 1. So 4 times negative 1 is negative 4. And then negative 16 times negative 1 is positive 16. So we'll get a positive value. So that means the function is increasing between negative 2 and 0. Now we can find the sign of y prime at x equals 1. So we have y prime equals 4 times 1 cube minus 16 times 1. Now 1 cube is just 1, so 4 times 1 is 4. So we get y prime equals 4 minus 16, which will give us a negative result. So that means the function is decreasing between 0 and 2 because we got the negative. And now we can find the sign of y prime for x equals 3. So 4 times 3 cube minus 16 times 3 y prime equals, so 3 to the power 3 is 27 and 4 times 27 is 108, and then minus, and then 16 times 3 is 48. So in this case we'll get a positive result. So that means the function is increasing to the right side of 2. So now we can find out where the critical points represent local maximum, local minimum, or neither. So let's analyze the first critical point at x equals negative 2 on the left side. So here we can see that to the left side of negative 2, the function is decreasing, and to the right side of negative 2, the function is increasing because the prime of y is negative on the left side and prime of y is positive on the right side of x equals negative 2. That means there is a local minimum at that critical point, which is negative 2, negative 16. So there is a very important concept you need to understand and memorize about analyzing local minimum and local maximum. Now let's analyze the other critical point, which is at x equals 0. So to the left side of x equals 0, the prime of y is positive, and to the right side of 0, the prime of y is negative. That means at x equals 0, the function changes from being increasing to decreasing. So that means there is a local maximum at, and that critical point is 0, 0. Now we can analyze the third critical point, which is at x equals 2. Now to the left side of x equals 2, the prime of y is negative, and to the right side of x equals 2, the prime of y is positive. That means at x equals 2, the function changes from being decreasing to increasing. That means there is a local minimum at negative 16. So this answers the second part of the problem, where we found out where the critical point is local maximum, local minimum, or neither. Now we have to find the x and y intercepts for the function and then sketch the function. So let's start with the x-intercept. So I can use a different color for this. So for x-intercept, I have to sub in y as 0 in the given equation and then solve x. Now we have to solve this equation. So the first step is to do common factoring on the right side. So we can factor out x squared and we get x squared minus 8. So we get two cases. So the first case is x squared is equal to 0, and we can apply square root to both sides to change x squared to x, and the square root cancel each other out, so we get x equals 0. Now we can analyze the second case. So we have to set the square minus 8 equals 0. And to isolate x, first we should add 8 to both sides. So the 8's on the left side will cancel each other out. So we get x squared equals 8. And now we can apply square root to both sides. So on the left side, the square and the square root will cancel each other out. And we get x equals, the square root of 8 can be simplified to 2 square root 2. So we get plus minus 2 square root. So as you know, when we apply square root to solve an equation, we get two cases with plus and minus. So now we can write out. So I'll just move to this side. So our x-intercepts are, so the x-intercept. So the first one has the x value equal to 0. And we know that that is also one of the critical points, that when x is 0, y is equal to 0 for the given function. Right? Now the other x-intercepts are 2 square root 2 and the y coordinate will be 0 because these are x-intercepts, and the third one is negative 2 square root 2 0. Now we can find the y-intercept, and for that we'll sub in x as 0. Now if we sub in x as 0 in this equation, so we get y equals, so 0 exponent 4 minus 8 times square, which is equal to just 0. So the y-intercept as a point is 0, 0. Now we can use all of this information to sketch the function. So I will draw the grid. Sorry, this one. So first we should plot the critical points. So the critical points are 0, 0. So that's the origin here. So I can use a different color. So the first critical point is here, the origin. The second critical point is negative 2, negative 16. So let's assume negative 2 is here. So negative 16. So the second critical point is here. And then the next critical point will be, so 2, negative 16. So let's assume this is 2. And so the next critical point is here. Now we can plot the intercept. So the x-intercepts are 0, 0, which is also the critical point. And the second x-intercept is 2 square root 2, 0. So that will be slightly to the right side of this point, is 2 square root 2. So this is a point that lies on the function. And then the other one is negative 2 square root 2. So the points that lie on this function are these x-intercepts, these critical points, and the critical point is also the y-intercept. Now we can use the results from the first derivative test. Now to the left side of x equals negative 2, the function is decreasing. So that means the graph has to slope downward from left to right. So we can draw the curve. I'll use a different color here now. So we can draw the curve like this. It will pass through the x-intercept and get down all the way to the first local minimum at x equals negative 2. Now between negative 2 and 0, the function is increasing. So between negative 2 and 0, so the function will go up from left to right. So as you can see, as you go from left to right, the graph is going up, and it will go all the way to the local maximum at 0, 0. And then To the right side of 0, the function is decreasing. So as we go from left to right, the graph should slope downwards. And then to the right side of x equals 2, the function is increasing. So as we go from left to right, the graph should slope upward. So this should be the sketch of the given function using the different characteristics that we identified using derivatives. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.